UEFI running, from the UEFI running on the server cores, that just to make sure that we're all on the same page as to the initiator is the, what is traditionally an x86 core, and the target would be the XPU, and the entity that's doing that is UEFI, traditionally called is that something Joseph's saying? Lots of wind and big gray wall. Oh, you're talking about your condition over
I'm talking to Dan Daly. Just please proceed.
Yeah, got it. Okay, so in what I'm proposing is based on some of the experiences we've had with DPUs in the field, or trying to get them launched. And how can we solve it for the mass audience, for a multitude of DPUs from multiple vendors? We certainly do not want to have unique approaches from each vendor. And this, I don't think I can emphasize this enough. This is an approach at the very lowest level of where a DPU integrates into the server. This is before things boot up, right? Before things have any, it's the discovery, sort of the very early discovery phase and booting up of the server and the XPU, where this comes in. And so what I'm proposing is a PCI. This shouldn't be a proposal, but one of the challenges we have is that some of the DPUs in the marketplace today, there are PCI violations, and so we want to make sure that there are no PCI violations, that the card is up and running 3 seconds after P reset is deasserted, that the card will respond correctly to PCI configs. And another thing is that in the software-defined world of XPUs, where the PCIe manager may be running in software, we need to make sure that the card is responsive, whether the software is locked up or halted or stalled, that the PCIe manager is still functioning. And I stopped short of saying it should be hardware defined, but I didn't want to impose that limitation, because there are potentially there are still software and some software methods that can guarantee a response. So, for instance, a very high priority thread or something like that. But basically, we want to make sure that in the event that the card locks up, that it will still respond on the PCIe bus, so that we can know it's locked up and don't think that it's disappeared. Because if the card stops responding, what the conclusion will draw from that is that the card is not present, right? It's just, there's just a ton of history in our code that has that assumption in it, and trying to change that is we'll probably have to do that over time, but that's something we need to be cognizant of. So after stating the obvious, then what I want to propose is a new PCIe class code and its corresponding PCI architected extended capability structure. So I don't know if you're familiar with this, but many of you are, I'm sure, is that there's a class code and it sort of points to a structure, and the structure has some clear definitions to it. I also want to propose that there are 2 subclasses, and I'd like this group to chime in on that, and that is one subclass that says this card does not have an AMC, and the second one that says it does have an AMC. And for those that are new, an AMC is an added card management controller. So we've sort of made a distinction to avoid confusion, that there's an AMC, which is what's traditionally been called the BMC on the XPU, and then there's the the BMC, which is the legacy baseboard management controller. We've been using the term BMC. We've been overloading the term BMC to mean both the motherboard management controller and the add-in card controller. But now we're trying to make that a very clear distinction between those two. And yeah, thank you, Boris. And so there will be two subclasses, because from a UEFI/BIOS point of view, we think, well, we could, they may be different they may be treated differently, and they may want to be treated differently. So want to make that distinction. And then there's a set of registers that I'm recommended to be defined. One is an OS boot select. That is, there needs to be a read-write register that tells the card, from which the card determines where it's booting from. And now, so it can be networked OS boot or booting from null volatile memory on the card itself, whether it's a maintenance mode or UEFI or some OS that's running on the card.
Are you saying that these are like supposed to be enumerations, or are you going to enumerate? Well, so one concern I have about this is, like, network boot target would be kind of some UEFI path normally, right? And that's going to be different from one XPU to another. I mean, you could have 3 or 4 or how many ever network interfaces. I mean,
right. And so this is just the bit that says it's going to boot from the network, and there's going to be some actual higher level constructs that are required to actually give it the path. This is not addressing that complexity. This is just saying where it's going to boot from, or, is it going to boot an OS that's on the card? Is it going to boot from the network? Is it going to boot UEFI?
yeah, I mean, if you're doing a secure HTTP boot, you would have to potentially give it the server certificate, right? Which could be huge.
Right, and this is not addressing that higher level construct at all.
Okay.
That will have to be addressed by something else.
Raise a question on point number 1 here, which is 1.1. The definition of functional, I'm not saying we have concluded now, but the definition of the fact that PF0 is functional is somewhat relative, in the sense, for example, if people are deploying the XPUs to be able to implement some functions such as security or anything, when we say that it's functional, is it including those services, or is it just like be able to do RxDX to load images and things like that functional? And if it does, if it is the later one where it should be just looking like a standard NIC, then is it bypassing some of the security aspects of things and all that for that period? So something to think about. I'm not saying we have to conclude it right now. And this is a dilemma that I've been always up against, to say that, if it looks like a classic NIC, then maybe the purpose is not solved. And if it doesn't, then 3 seconds may not be sufficient.
Yes, so I'm glad you brought that up, Vipin. This, in the first statement, this functional here refers to PCI config accesses only. Maybe I should put only in there. So this is not the higher level capability of thinking that, other functions on the card will be available, right? This is physical function 0 config access.
Sorry, go ahead.
Thanks.
Yeah.
Reza, you okay taking notes? Because I'm sharing, I cannot take notes. Without...
Yeah, I'll make that adjustment.
Thanks.
Yeah. And Lee, did I clarify what you were asking?
Yeah, I think so, but it just means that, I mean, we're kind of punting on the problem, and we'll have to figure out something else to.
Yes. Again, this is this is the, I don't know, this is where it's the most initial piece of the boot up phase, right? These are the capabilities that we're saying that needs to be there. Continuing, another register, which is number 4 there, would be an OS status register that says, yes, the card it hasn't started booting yet, it's booting, it's booted, it's stalled, or it's halted, some status. And, you know, these are not written in stone, right? As Boris says, this is a proposal. We'll need to massage these, entertain other suggestions, you know, include other capabilities, other bits that need to be defined.
So I'm sorry, question back on the, you know, with number 3, trying to kind of map it to whatever the UEFI attributes are. I mean, is this a one-time non-persistent boot? Is it persistent, but you know, when does a bit clear, right? Because, you know, they have a boot order potentially in UEFI, right? So
Right.
how does this interact with the UEFI boot, right? And I mean, the maintenance firmware could even be before UEFI potentially, right? So
Correct. Again, so that's a higher level construct. Maybe that's a good suggestion. Maybe we should add another register that provides the boot order.
yeah, well, I think you're gonna have to, I mean, before you, is this gonna go before the PCI SIG, and then you're gonna try
Yes.
and proposal and then go I mean,
Yes.
I'm sure other people are gonna have these same questions of how it would interact, right? Like,
Right.
have to probably be defined before you could get it approved, right? So,
Yes. Yes. I'm sure there'll be lots of discussions before it gets defined. Yes. But our intent is to propose it to the SIG.
Okay.
Reza, if you can take that note as well, I think it will be useful to put a note here on the high level that the intent is to propose to use to PCI Express SIG and not handle it completely inside OPI.
Will do.
Time to go.
Okay, please continue.
Just taking this note. Okay. The next one is the crash dump status, and there 3 bits are defined: not started, in progress, and complete. And then a register number 6 there, a register to indicate to UEFI what's the maximum time that this should take, this device, this XPU should take to boot, so that we as platforms can, you know, make a decision on how to handle a card that is not completing the boot. And I just arbitrarily threw in 1600 seconds in there as the max. We can, you know, as a group, we can figure out what that number needs to be. I would recommend that, you know, whatever we think the max is, you know, how long it would take an XPU to boot, that, you know, we have 3 or 4 or 5 times that amount as the maximum capability in the register. So, but that's left for our discussion. And then the number 7 there is, you know, as a reset register, because the XPU has got many different pieces to it, and we may need to reset them as a whole, as the entire card, or individual pieces. And again, this is open for discussion. But you can see there the PCI interface, the CPU complex, meaning for what we are aware of today, or for all that we're aware of today, there are ARM cores, but that could change in the future. The AMC on the card, and if there are accelerators on the card, maybe we may want to independently reset that, or, you know, maybe those could be reset simultaneously with the CPU complex. I just put them up there just for completeness, but we certainly would like to have some discussion on that. The whole idea behind these set of registers is to create a Buddha flow for UEFI that can check the status of the OS that's booting on the XPU, and then handle any contingencies that occur. So the contingencies are timeout, lockup during boot, or crashing during the boot. So that's why I'm recommending this set of registers. So
thank you, Reza. I think this was very helpful. Maybe just one more comment. I really like this diagram that Lee created for the out-of-band management. Maybe you can also try to create one diagram for how the sequence will look like if this is in place.
sure.
Like what BIOS will have to do on the main and all the replies and the status. So maybe it will just help to clarify the flow a little bit.
Sure. I do want to add something for the out of band, and that is, I also want to recommend that these registers be accessible in the out of band. And this is just to complement what Lee has proposed here, using some PLDM or whatever method, that these registers be accessible through out of band. And for future products, we certainly would recommend that out of band access be USB. And that's the next section that I'd like to that I started writing up, wasn't able to get it in. But I think it will be a good complement to what Lee has proposed here.
I agree. Action item for everybody on the call is to take this proposal really seriously. I know that some people were really against this physical function 0, so we need to make sure that people aware that this is currently the proposal number 1. It's not, we haven't decided on anything yet. Obviously, there are a lot of holes here in this proposal or shortcomings that you see. It wasn't intended to be a comprehensive solution yet. But at this point, what we ask is both the server vendors and DPU, IPU vendors, please take this back to your companies, discuss it internally, and please come back with your feedback. You can post the feedback on GitHub, you can post the feedback on Slack, you can post the feedback on mailing list, but I think that we need to get this going. If you have objection to this, please be vocal about it. If you have additions, please do so. Tim, you have your hand raised.
Yeah, one comment is seems really important that the PF0 functionality is in hardware. It's not dependent on the CPU complex on the DPU in order to meet these requirements. And then to your comment, Boris, what were the objections to physical function 0? That seems like an obvious path to go down to me.
I don't want this was under NDA, but I know some companies that expressed the concern of exposing the physical function 0. So I just want to be vocal about it and go ahead and those companies go back and discuss it and come back with what rejections were. So
the objections weren't raised in this forum; they were raised privately.
yes.
Okay.
Well,
I guess they need to come forward if they really are serious about it. So.
Yeah, and
I agree.
And I raised this as an important effort that we're doing at the board level in the board meeting we had yesterday morning. So part of my summary said that this is a very important, critical effort for all of the companies in OPI, and in particular, all of the DPU vendors and server vendors to come to agreement on. And I apologize for jumping ahead of you.
Thanks, Joe. That's important. Thank you. Masay, you have your hands up.
Yeah, sure. Just one question. So, or remark, if PCI solution for, let's say, future generations of of the XPUs is going to be standardized, let's say, for the sake of argument. What happens with this solution if we have a host that we do not trust? Meaning, I definitely do not want the host if the deployment model is that the host is not trusted and should not manage the IPU. The boot selection and the OS status maybe, but the crash time status, all the other stuff, it's irrelevant to the host. It's from my perspective, this should be probably limited to just because we're mixing contexts here. It's one context is just synchronizing that the IPU is ready so that the host can utilize the services. The other context is host is managing the IPU.
Yeah, this particular proposal is for the case when there is no AMC on the card.
But Masay, I agree with you. I think there is a little bit of mix-up. I agree, but the statuses, at least the crash dump statuses, are all read-only. You don't need to trust the host to provide him like I'm doing this or doing that. At least for these statuses that I see here. But again, please put comments what you think is better. Yeah.
All right.
Most of the core things, correct me if I'm wrong, Masay, but the core things here of just focusing on the boot synchronization itself are okay by you, right? There are a lot of some concerns that, taking a little bit of share in addition to that, but the core of the proposal is not disagreeable, right?
Well, I have my own doubts regarding whether the whole thing is implementable on the hardware that we have, but that's
Okay.
the other story. But yeah.
Which is important, right? As DPU
Mhm.
vendor, you can raise those concerns. Absolutely, we're welcoming that.
Don Daly is waiting for his turn.
Yeah. Okay. Cool. So let's put a pin in this number one. You have your action items. Reza have his comments to incorporate in this proposal, and I want to shift focus to now proposal number two, which is based on option ROM proposed by Intel, and then you have your floor. Go and walk us through this.
Yeah, so this race condition is something that we have had to address in the past. I would say the first time it came up was with NVMe, where you need to, before you can boot from NVMe, you need to not just have the initiator up and running, but you need to have your path all the way back to the target to host your boot disk. And so the way this was solved is that to ensure that the infrastructure is ready to serve the host with whatever it needs over the PCI, it has to do some sort of ready check on the driver side. So the nice thing about this is that because it's happening in the driver, the BIOS doesn't need to change, UEFI doesn't have to change, the PCI spec doesn't have to change. The synchronization, and of course, the assumption here is that everything boots up in parallel. So, the shared power is how PCI cards work. So, you're assuming you're in a shared powered environment, the host and the card effectively boot up at the same time. The BIOS will undoubtedly get there first, especially since if you have to wait until some connection with the backend network is established. And so in the case of VirtIO, VirtIO doesn't have a nice, cool little bit in the spec like NVMe does. So in the case of VirtIO, we implemented a it's a device specific signaling between the driver and the backend that basically does a ready check to make sure that in the case of VirtIO Net, that the network is ready to enable a PXE boot. And in the case of VirtIO Block, it works the same as NVMe, is it makes sure that for especially the bootable disks in that controller, that they're ready and accessible for the BIOS to go and access. And that the Verdeo block and the NVMe are essentially the same function. Just NVMe is better because it's a explicit bit inside the standard driver. So this solution is really nice because you make zero assumptions about what server that this card is getting plugged into. You don't have to worry about versions of BIOS, PCI spec, compatibility, none of that. It's all sort of self-sufficient in that, especially with the OROM, when you have an option ROM, the driver for that device and the BIOS comes with the device. So you have a pairwise, you control both ends, and you can use this to resolve the race condition. And so we use this today in lots of different environments. And this is also a solution that would not be very compatible with the proposal that was previously suggested, in that these are standard devices. So, we couldn't really put another function in PF0 because PF0 is probably VerdioNet or NVMe. So we can't go and add something there. Or maybe we can. It's super complicated. And so, and also, I posted the answer to our survey, and that and how an IPU, we have a couple different IPUs, honestly, how they're provisioned, and they really provision like a multi-host NIC. And in a multi-host NIC environment, the host doesn't have any like direct path to go and understand what's happening on the embedded cores. So there's no way for the host to even know that there's another host attached, and that maybe that other host is running infrastructure software. So that really has to happen at a higher level of trust than either in band like the previous proposal or something through the driver. So there's no way to at this level go and find out, hey, are your cores running infrastructure running or not, or are they booted? So that this mechanism also keeps it really clean. I don't have to trust the host. I don't have to expose any of the inner workings to the host. Keeps everything really clean.
So I want to open the floor to questions to Dan and Intel team. Before that, just one quick comment from the organization perspective, Dan. I think that at least this sentence, maybe I would put it in a subsection of assumptions or something like that. So we have clear kind of assumption thing for the driver ready check option number 2. Or maybe these benefits that we were talking about previously, I think are very important, and I'm not seeing them clearly here as well. So I think that will help to clarify a little bit the benefits, maybe of this approach, or shortcomings of the previous approach, and the assumption that you're making on the PCI Express bus here.
Yeah. I think that the fundamental assumption, and this is it goes into more detail on the IP survey answers, is that you really can't get around the base assumption that this is a PCI card and everything's going to kind of start up at the same time in parallel, and that when PCI enumeration happens, you can't change that. So that has to happen. Your device has to be ready at PCI enumeration time, or else things don't really work. So that's why I have that. I have that sentence there. Yeah, I put this in to try to make it pretty brief in terms of the solution, but I can put in a little section about these advantages, is that it makes zero assumptions about the platform, and you can essentially put this IPU DPU into any card and have it and be able to offer boot services into any server, and be able to offer these boot services to that server.
Yeah, no, I think that's clear. And if you can put it as explicit section, small section, again, doesn't have to be long, but I think it will help. So Reza, Lee,
Yes.
others, feel
Yeah,
free to jump in.
I do want to comment here. So thanks, Dan. And the thing I just proposed is all about meeting that assumption in that last statement. It's only addressing that last statement that you have there. It's what happens at enumeration time. That's all I'm addressing, because that's where we're seeing the challenge today. Everything else you've stated comes after that.
Yeah, so yeah, all of our IPUs have to follow the PCI spec, so we follow that. And I would think that this would be the most sensible thing for us as OPI to go in and assert, is that, yeah, you have to have your devices that you want to give to the host ready by enumeration time. And that's a very clear spec as to how much time you have it, what you need.
Yeah, I think Dan and Reza, I think the disconnect here is we know devices, and Vipin, I acknowledge your hand raised, just 1 second. We know today there are devices that implement the PCI Express in software completely. So you cannot make that assumption that they up and running like today traditional NICs or even Intel. If Intel is completely PCI Express spec compliant, we applaud to you and great job. The problem is with rogue devices that are breaking today the PCI Express spec. And one of the reasons is because they implement the PCI Express state machine completely in software.
Yeah, so my immediate question is, are we striving for having workarounding specs, in this case PCIe, meaning, for example, we are designing for a future product, from what I'm seeing, at least. For at least from PCI perspective, the first solution is we're designing whatever it is, but whatever is in the point one, it's going through the PCI SIG is going to take a lot of time, definitely. So that's something future product proof. In this case, the driver ready check seems to be at least an easier part, at least for the devices that are PCI spec compliant. So my question is, are we designing something for the current devices, for future devices, or?
I think it's a recognition that the world is changing and we're moving away from a hardware-defined world to a software-defined world. And our specs need to evolve to accommodate that. Now, I mean, we can put our foot, I would love to put my foot down and say, thou shall be hardware and you will be ready. If not, we're not going to use you. I would love to do that. But I think we recognize that everything is changing around us. So, you know, a particular DPU, its personality is dependent on the software that runs on it. This is very different than a traditional NIC or a GPU or any other accelerator.
I mean, you're having the problem, the overall problem that we could generalize is basically it doesn't matter if it's a DPU, IP, or whatever. If we have a device that's not necessarily PCIe compliant at current place, but definitely is it would be a functional device once we gave it more time to be ready. Then yeah, the proposal here is the proposal here in the point one might be a viable one, right? In this case, but considering that, I think we are going to be stuck with two options and two implementations. Because for some people you have software defined thing on the one, right? It's for the point one option, and the point number two, it would just work for the devices that are PCI spec compliant.
Yes.
Let's give a Vipin chance to respond. He was very patient, and then we can continue the discussion.
Sounds good, thanks. I do have a question and a comment. The question really is that, approach 2 is effectively saying there needs to be a hard function. When I say hard function, as in hard-coded block on a DPU, which performs the standard NIC function And then there is a DPU complex. Effectively, you're juxtaposing two NICs in one form factor. The NIC that looks like traditional NIC, it could be, I'm hypothesizing, let's say even 1000 NIC in case, and that's what shows up on the host, and everything else is things under the iceberg. No one knows about it. I recognize the use case where you don't need to know the details of what's happening underneath, and the trust points are different. Completely agree with that use case. But I'm trying to ask the question as to, is it assuming that it has to be a hard-coded block on an XPU? And then I have a comment, which is going very much in line with what Reza was saying, is that to give a clear idea of what that NIC is, at least for the Pensando devices, we could look like a NIC that is not defined yet, for example, because it's programmable. I want to cater to those kind of use cases where PCI programmability is something we want to encourage. When I say PCI programmability as to our device is exposed, what it looks like, what personality takes, if that is software defined, then you got to give it some time to take that and assume that personality. It cannot be hard-coded. So it goes back into the question I was asking earlier. If you want to encourage that kind of implementation, then yes, it's very different from a traditional hard-coded standard NIC. On the other hand, we can say, no, we don't. We want to layer it. I wouldn't say we want to discourage it, but we want to layer it. That you have your soft functionalities somewhere south of that PCI function, but then you have already exposed a PCI function, and you can't change it. You can only expose yourself as hard-coded blocks that you have included in your XPU at the time of definition, which is the trade-off here. Just
Yep,
to
we're
give
not
you
saying
some
that,
sense of.
Don't make that assumption. Yeah, so that's not what we're saying here.
Oh, okay,
Yeah.
so if we don't make that assumption, we still assume that certain kinds of devices are to be exposed, and so there are two parts to it. The first one is that implement the PCI function in software. That's not what I'm saying. What I'm saying is that as to what devices you're exposing to the host. And if it is configurable, then that configuration needs to come from effectively a non-trusted entity, which is not host in the argument you were making, Dan. If that is not the host, then that entity needs to give that personality to the card and what devices needs to be exposed and all that. So how do we do that if we want it to be configurable? And of course, I mean, just to give you a small glimpse of how we handle it today in Pensando, is we just put the entire operating system in 2-3 seconds and done with it. It's just that we have a conflicting goal here to boot a general purpose operating system and do this whole 9 years of thing, which is needed because you want to enable common stack to be running on these DPUs. I'm just saying that if we want to have both of these things, that's when I think the proposal number one probably comes into play.
Yeah, so I'll address some of the earlier things. Yeah, so I mean, we definitely want to have software-defined devices, and you can absolutely have that. In the IPU provisioning document that I posted yesterday, I do talk about as an option if you want to be able to have dynamically hot pluggable devices come in and out of the PCI, still adhering to the PCI spec. You can do that as long as you set up your BIOS to have hot pluggability. And so, we don't, not all of our IPUs have a hardened NIC inside. So that's not where we started. So they've always been very, very software programmable. But you have to follow the PCI spec. So the PCI spec says, hey, either your devices are available at enumeration, and in which case you could have any device you want. Like I list here 3 devices that are, out there, and it's understood how these work. But we have other devices that kind of do the same thing. So you could have a programmable device that just needs to have this device ready check, and you are good to go to boot from it if that's what you need to do. Or if
so technically what you're saying, Dan, is the PF would be healthy. You might even have a bar, let's say, or at least a bar with some registers where you could technically write, let's say, DMA address for a queue that you're going to be talking to firmware, for example, or exchange the communication with the XPU, and then you might time out on the communication on that path instead on the PCI level.
Yep, it can be, it's device specific, right? If you have an option ROM that is given to the BIOS, it can be whatever that device needs it to be. And so, you know, so this option.
If what you're saying is, if I understand correctly, how is different from the first proposal, having the physical function 0 always ready, have the registers available to you. Maybe we don't agree on the name or the functionality of the registers, but for me, it's almost the same that what you're saying. And then the option ROM comes after that, after the first enumeration.
No, that extra PF you don't need. And if you have a hot plug interface, you may come up with 0 PFs at enumeration time, and you may add them sometime much later to that host. So, you know, so these are sort of standard interfaces that you know, here we have 3 examples. There are others that do this driver ready check before you can boot from them, or you can access them in a BIOS context. And you know, this works and makes no assumptions on the platform. And so if we say, and you can still make it programmable. So if we say, you know,
make
hey,
an assumption, like you said, the device must be ready on the PCI Express bus at enumeration time. And that, I think, that assumption is what Reza is challenging with his first proposal.
Yeah, and so I'm saying if we say, you know, within this OPI context, we need to go solve that problem, then I don't think that we should be saying, well, you know, in order for you to be an OPI compatible DPU, IPU, whatever you know, you have to have this PF0 device, because that's not the problem that we're solving. You know, I would be perfectly fine with saying, hey, for some devices, we need to have this PF0 thing, or we could have a PF0 that all it does is a driver ready check and doesn't do all that information. It just tells you if your device is ready or not. I would be fine with that, but that isn't to make it DPUable or IPUable. Like the solution here already works and solves the problem without having to add anything. So I would say that I'm not against doing, you know, a sort of a more generic driver device just to fix this race condition for the highlighted piece. But I don't think that we should make it something that, okay, to be OPI compliant, you need to do this thing, and you need to have BIOS and server changes and things that are checking for it, because it's just not necessary.
Thanks, Dan. We have Tim, his hands raised up. Just Tim, before you go, Dan, at this point, we don't exclude all the proposals. I think all 3 proposals at this point are equal and should be considered equally. So whether people see advantages and disadvantages along proposals, we still at the consideration mode. So I want to encourage everybody to keep their thinking hat on and continue to look at this and not kind of dismiss any of the proposals, and really, really seriously consider all of them.
I know. Just someone said earlier, like, you know, someone should speak up, and so speaking up here is
representative
to give my perspective.
Thanks. Tim, go ahead.
Yeah, so the text here in number 2 is not quite illuminating enough for me. Maybe I don't have enough context. So Dan, could you be a little more explicit on how the driver ready check works? Is it using the expansion ROM capability of PCIe?
Yeah, so I go into more detail in the IPU provisioning doc. It didn't get approved yet, but it's on the website, and I go through the sort of the entire philosophy of how we boot our IPUs. I understand this doesn't have any pictures or any flows,
right,
like,
but what is required of the card in order to do the driver ready check?
all you need to do, every card has to do this already effectively, is that when your device is running inside the BIOS, most BIOSes won't have the driver for that device. And so the BIOS will go grab the driver out of the option ROM. And so it'll pull out the image of the driver for that device, load it, and then use that driver to access that device.
The assumption you
so-
have some kind of physical functions and PCI Express enumeration already happened, right?
Yeah. So
Yeah.
let's say my card comes up and it has 2 VirtIO nets and 3 VirtIO blocks on it. And so, those devices will come up in the BIOS, and then the BIOS will go through and if it needs to boot an operating system, it'll look at those devices to see if it can either PXE boot or if any of those VirtIO block devices could work as a boot disk. And so in both cases for VirtIO, the VirtIO driver is not in the BIOS. So the BIOS has to go and grab the driver from the option ROM.
And that option ROM also manages contingencies.
Contingencies.
If
Like
it
what?
locks up or
It's just a driver. So
errors during the boot process, those kinds of things.
Yeah, so if you're unable to boot from those devices, you'll be stuck there, right? So that's not something that the UEFI can necessarily help himself with or help itself with, because all it's doing is trying to boot. So the IPU DPU here is offering a service to be able to boot the host from a presented
Right,
device.
but this
That's the
all
feature.
presumes that the card is on the bus, the BIOS
Yeah.
has done enumeration, it's discovered
Yep.
there's a boot ROM and what address it's at,
Mhm.
right? And then he can go out and pull the code out of that boot ROM,
Yep.
right? And then that code itself is the device check, you're saying.
Yep. That code
The
itself will have.
the code will do something proprietary to that device that will allow it to determine that, hey, my device is ready, I'm gonna hand control back to the BIOS.
Yeah, my device is ready, so I'm going to go and do the first read of the disk, or I'm going to do the first packet send on the port.
Or
to go-
or in the UEFI, you might even delay that by using events.
Okay.
Yep, you can just wait for an
That's clear. to me.
event for it to
Thank
say I'm ready.
Vipin,
Then I have a quick comment. Basically, proposal 2 is saying that make it work with the way standard. And
It's
not
just me or
that's
we're
what
losing
PCI
Vipin?
expect.
No,
Yeah,
we're
we're-
losing.
Sorry, can
Vipin,
Okay,
we're
can you
losing
guys
you.
hear me
broken
now?
up. I don't know if it's my.
No,
my
no,
side
it
or
must be
yours.
me. Can you hear me now?
I can hear you
Yes,
now.
that's better.
Okay, sorry for my connection is quite awful right now. So I was saying that then it looks like the proposal 2 is really status quo of how a standard NIC behaves. There is no proposal as such on changing anything with respect to how any NIC behaves. I mean, UEFI and the boot process and supposing PCI devices, honoring the time limits of what PCI expects, hot pluggability, all these things are standards with NICs. And if we were to do and behave like a standard NIC, then this should just work, is what this proposal really is. I'm just trying to rephrase it that way.
That's right. This works in both cases where the device is just a peripheral, and it works in the cases where the device is infrastructure and there's that trust boundary. So it works in both cases. And the reason why you have to stay within the PCI spec is because you can't make any assumptions with that trust boundary in place about what's running on that server. So you don't really know, you don't even know what kind of BIOS it's running, right? So you have to go to lowest common denominator here. I mean, there's nothing more lowest common denominator than VirtIO. So you have to live within those confines. You can still have programmable software-defined devices in that lowest common denominator space. but you have to follow the PCI spec.
All right, I think we're out of time today. I think this was great introduction into all three choices that we're currently heavily considering. I want to thank Reza and Dan Daly and his Intel support team as well for putting up with these two proposals, and Lee Ballard for putting up the out-of-band third proposal. This is great. Please take an action item, take it to your internal companies. And next week, we're going to have a very lively discussion like we have today, with more details and more backup from your internal investigations that you already did on those three proposals. So please come prepared, and see you next week.
I won't be here the next 2 weeks. So sorry
If you
about
can
that.
send somebody, yeah, it will be great. Thanks.
Cool.
Hey,
Thank you.
Boris, all this is available on the provision lifecycle API, but not provision lifecycle GitHub page.
Yes, I posted the link in the chat. You can
Got
grab it right now.
And
Got it,
Boris,
got
if we could get the IPU survey approved, then more people could look at it. I think it gives better background. That I was really brief in this section.
Sure, I'm just trying to figure out the folder structure where the best to put it, and then we can, yeah. I'll work with you. Fine.
That's great. Thank you. All right. Thanks, everyone. Bye.
Thanks.